It's a privilege to be here with you and share this information with you. And I hope you go away with something more than what you came with, and we'll have a good evening. I humbly identify myself as a student of the soil. That journey for me started in 1989. I have absolutely no problem admitting the more I know I don't know. In 1989 is when I started using what we called at that time alternative farming on our family farm. Today we call it biological crop production. In 1992, because of the success we had on our farm between 89 and 92, I decided to start sharing this information with others. That's when I guess I became a crop nutrition advisor, crop and livestock both, focusing on working with the soil, learning how the good Lord designed it and how we should work with it and not against it, and for the benefit of everybody involved in the food chain as well as the soil. I also worked with livestock producers, and their primary focus was on feeding animals without the need and the use of antibiotics. We were quote-unquote natural before it was really a term. And the experiences that I've been able to help these amazing family farmers all across the country, it's been amazing. They were the research field. They paid the price for the research that was conducted, and I'll share with you a lot of those experiences this evening. I am the primary coordinator and a co-author on a lifetime feeding study of feeding genetically engineered crops to pigs as a meat animal. I'll share more about that with you when we get to that point in the presentation. First, I'm going to give you a little basis on the genetically engineered crops, and GMOs and genetically engineered, I'll refer to it one and the same. And I realize I'm speaking to a vastly educated group in that regard, and I'm glad to see that education level's increasing everywhere I go. I can tell you I became a student of this subject in 1994. So, and then started with the hands-on on-farm view of it in 96, 97, and going forward. So, I'll share with you what we learned, and then the concerns that we have beyond the production agriculture aspects of it. The objective of agriculture: to produce a safe, affordable, nutritious food supply at an affordable price. Also, we need the fibrous materials and the commodities necessary to support our society. Now, agriculture is to be the basic infrastructure of society. Relative to this technology, have farmers been told the whole story? Do the conveniences of the technology, which I'm going to share with you, come at a price other than the obvious price that you're going to see as well? Are there side effects to these conveniences in implementing this technology in your cropping operation for your land and or your animals? If there are side effects, who will be responsible for them? Will it be the individual who has purchased this new technology to use, or will it be the entity that has collected the money spent on it? As Pam mentioned, I have the amazing privilege of working with some of the top scientists and researchers from around the world in their respective fields. I'm not going to spend a lot of time on this. There's only one scientist on here that I don't communicate or work with in some manner or fashion with some regularity, and that would be Dr. Carrasco, but I will reference his work. And I noticed the other day when I was looking at this that I really need to update it, because I could make a whole nother slide with the amazing scientists I get to work with. The most common genetically engineered crops that we have in production in our country to this point in time, I'm going to start with the BT. That's the crop that has the insecticide in the plant, in every cell of the plant. BT represents Bacillus thuringiensis. That is a natural occurring soil bacterium that organic farmers have been able to use for many, many years against certain insect infestations. And if I hold this, it'll work a lot better. The insects that the BT would control, the farmers would see the presence of this infestation and spray this material on. The insect would ingest that natural BT. That natural BT would eat a hole in their gut. They die. The material returns to the soil in a benign manner and fashion, and life goes on. The genetically engineered BT that we have is not something that you spray on and can wash off. It's not like another insecticide, whether a natural version or a synthetic or chemical version, that you can wash off. It is in literally every cell of the plant. Now, they have told us we don't need to worry about it, that it's fine, it goes away, it's not going to harm anything on up the food chain. And yet science is showing us that that's not necessarily true. And I would reference the Aziz study in Canada in 2011, when they found the Cry1A-BBT toxin in 93% of the pregnant women's blood that they tested. And these women, 80% of them passed that toxin on to their baby's blood. That goes against what we told would happen. The herbicide-tolerant crops is far and away the #1 reason why this technology has been implemented by farmers and embraced by farmers all around the world. Roundup Ready crops and Liberty Link crops. We're going to talk about them more Roundup than we do the Liberty, but in essence, both of these chemicals are designed to kill virtually everything they touch. And the crops that we have in production in our country to this point in time, glyphosate is the active chemical ingredient in Roundup herbicide. I'd say you'll probably hear me use the word glyphosate at least 50 times in this presentation, if not more. We have glyphosate-resistant alfalfa, canola, corn, cotton, soybeans, sugar beets in production. We also have glyphosate-resistant wheat that's been developed but is not in production. The active chemical ingredient in Liberty herbicide is glufosinate. It is slightly different, but yet similar to glyphosate because it's designed to kill everything it touches. We have the canola, corn, cotton, soybeans, and sugar beets in production in our country, and the rice has been developed but not put on the market. The goals of genetic engineering. We're told, #1, that we need this technology to increase the yields, to increase the food supply, to feed the growing population of the world. There's no question that we need to feed the growing population of the world. We're told that we need this technology to increase the nutrient content. Those two claims, myself and all the scientists that I'm privileged to work with, are totally supportive of utilizing this technology, focusing on that. Let's take the technology and perfect it and get rid of the side effects and utilize it for these two purposes. We're completely in support of that type of technology. But as you're going to see, that may not be the focus or the outcome as to how it's been implemented to this point in time. We're also told we're going to have drought tolerance, the in-plant insect protection. The objective is to reduce the insecticide use. Everyone in this room would agree that that would be a good idea, to reduce insecticide use. Herbicide tolerance, we're told again, let's reduce the herbicide use. Again, everybody in the room, I think, would agree that's a good idea. The improved weed control and the ease of the weed control in the beginning is the #1 reason why it's been embraced around the world by the farmers. So let's take a look at what has happened to this point in time. Increased yield. In 1996, when the first glyphosate-tolerant soybeans or Roundup Ready soybeans came out, and we also saw BT corn introduced, the University of Nebraska, along with our other land-grant universities, were allowed to do yield comparison on the conventional version of the variety and the Roundup Ready version of the variety. The University of Nebraska started doing this testing in about the 2nd or 3rd year. We come to know a term called yield drag. It was documented consistently that the genetically engineered version of the crop yielded 8 to 10% less in soybeans. They had multi-year data. This went on for about 5 years. We got to the 5th or the 6th year, and all of a sudden we didn't hear about yield drag anymore. Well, the language changed on the technology agreements that the patent holder of that genetically engineered crop had, and it said it was in essence illegal for anybody to do research on these genetically engineered crops without the permission of the company. This progressed a little further down the road, and as our land-grant university researchers who are supposed to do this kind of research for production agriculture got more frustrated and started to hear problems about the BT failing and the insects building up resistance, 28 state entomologists sent a letter to EPA unanimously and anonymously saying, we can't access this technology, we can't do the testing on the seed. Well, as a result of that letter, there was a little bit of a loosening of the purse strings, you might say, on the seed from the patent holders of the genetically engineered seed. And they said, okay, you can have the seed, now you have to sign this form. Well, this form said before you could release these plot results, whether they were good, bad, or otherwise, you had to get our permission. I'll let you guess what happened to the plot results if they weren't favorable. There was also a report by the Union of Concerned Scientists published in 2009 entitled Failure to Yield. They analyzed all the data that was available from the research setting comparing the conventional to the genetically engineered, and it showed that genetically engineered yielded less. On our farm in northwest Iowa, we were a seed dealer. We started putting test plots on our one field in 1984, right down along the highway, and the seed company came to us and said, boy, that's a great spot for a plot. So we put a hybrid plot in there every single year. So we were used to doing this. When the BT came out, they provided the seed to us for the plot, and they provided the seed. We did not sign a technology agreement because I read the language in it and I said, I'm not going to sign that. I'll point out to you that first plot, that first year, we had the conventional hybrid on this side. All the fertility was the same on both. The seed cost on the conventional was $26.18. The seed cost on the BT was $38.18. When we harvested it, the conventional made $149.91. The BT made $146. It was only 3 bushel less. But the moisture was 5 percentage points wetter. That constituted to a dock of 25 cents a bushel when we sold that grain, and the bottom line was we lost $57.99 off our gross by having the BT. Now, we had heard that cattle were having some issues with grazing the stalks on the BT in Nebraska the previous year. So we did a simple experiment. We took a feed bunk and we put some of the conventional corn in one end of the bunk. We put some of the BT corn in the other end of the bunk. We put a couple stock cows in there. Stock cows and corn are kind of like kids and candy. The kids will leave the candy dish once it's empty. The cows ate the conventional corn, smelled the BT, and walked out of the pen. We'd never seen anything like that before. So we started observing it a little more closely. We were already looking at it objectively rather than euphorically because it sounded too good to be true. The next year we repeated this very same thing, side by side, everything the same in the plot. Bottom line was we lost $58.95 an acre off our gross on the BT the second year. Now the seed company saw this happen consistently in the plots where they put this hybrid. This was what we referred to as an old reliable. It didn't need the BT because it was a good sound hybrid. The plant breeders went the extra mile, did all their due diligence, and developed a hybrid that had high natural tolerance and or resistance to the insects. But there were some other hybrids that were kind of substandard as relative to insect resistance. They put the BT in that, they saw the response, they were selling the seed for more money. Which one do you think they promoted? The seed they could get to market faster, maybe taking a shortcut, and selling for more. The herbicide use rates. There's no question in the very beginning herbicide use rates went down for the simple fact we could use this chemical that was designed to kill everything it touched except that genetically engineered crop that had now been designed to tolerate it. In the beginning, when Roundup was first used, the rate per acre was 32 ounces per acre. Many farmers heard, well, you don't have to worry about a weed resistance problem, especially by the manufacturer of the chemical and the prime promoter of the technology. They said, don't worry about it. So they didn't. They kept using the same herbicide on the crop and the corn and the beans and the beans and the corn. Well, sooner or later, nature catches up with things. By 2010, instead of putting 32 ounces on per acre, there were many agronomists recommending 96 ounces per acre. Number one, the price of the chemical went down. They said it's so cheap you can't afford to not put on more. The weeds were getting iffy as far as getting a lot of them killed, and where they had solid resistance established from the weeds on soybeans, I know of farmers that put 96 ounces an acre on and made 3 applications in a growing season trying to kill some of the weeds that had developed resistance, and the original rate was 32 ounces. Dr. Charles Benbrook from Washington State University did a survey in 2008. He looked at the pesticide use in our country from the beginning till end, or till then, and he saw the same thing we saw. It went down in the beginning and then it came up. By 2008, it took 26% more chemical to raise a genetically engineered crop than it did to conventional. In Argentina, they introduced the Roundup Ready soybeans in 1996. They put on 2 liters per hectare. Same thing happened there. By 2010, they're putting on 10 to 20 liters per hectare. Insecticide use. The BT for corn was designed to work on European corn borer. In our part of Iowa, we would see enough of an infestation of that BT corn to justify an insecticide treatment 10 to 20% of the time. I remember the airplane pilot telling me, when I asked him what he thought of BT, he says, well, now you're going to use an insecticide all the time, when we had to treat 2 out of 20 years. He says, how much sense does that make? Well, from an integrated pest management standpoint, it didn't. Because in an integrated pest management standpoint, you scout for the insect, you put on the least amount of insecticide possible to control the insect, and then you prevent the resistance from happening. That wasn't the approach that was used with the BT. It was promoted that they should use it everywhere as an insurance policy. The thing that Dr. Benbrook couldn't do was measure the amount of this insecticide that went on top of the other pesticide he measured, because the other pesticide was measured in pounds. The insecticide and the herbicide and what have you. The state reports require that reporting. All of these plants that are containing this BT toxin are registered with the EPA as an insecticide. He couldn't measure that. Before we had genetically engineered crops, we never heard of a seed treatment insecticide. There would just be a mild fungal treatment on the seed when it came. Now you cannot get a genetically engineered corn or soybean seed that does not have a neonicotinoid type insecticide on it. These neonics have been banned in a number of European Union countries because, number one, they are having a devastating effect on the honeybees, contributing significantly to the colony collapse disorder. And there was a paper just published. They're also implicated now in causing nervous system damage to humans. What about the problem insects that we wanted to control? This is a picture of a corn plant. There's the stalk, there's the ear, there's the leaf. There's no silk coming out of the top of that ear because these adult rootworm beetles have chewed all that silk off. When they're there in a high enough population, they'll do that. I'll show you in the next picture what happens when they chew that silk all off. These adult beetles lay the eggs for the next year's rootworm crop. In the spring, the ground warms up, the egg hatches, the larva comes out, chews on the roots of that corn plant. When they're there in a high enough population, they chew them roots off, that corn falls down. Then they come back as the adult beetle, which I showed you on the previous picture. They chew all the silk off, and you notice there's no kernels on that cob. That's what they'll do when they stop pollination. The BT won't affect them, so if they come out in that population, in addition to have the insecticide in the crop, now you have to spray that crop with another insecticide to stop them from chewing the silk all off. And of course, if the corn's laying down, you're already in trouble. We have rootworm resistant, BT resistant rootworm in Iowa, Nebraska, Minnesota, Iowa, South Dakota, Nebraska, Minnesota, and Illinois. And the problem keeps intensifying as each year goes by. So what's the motivation? Is it to grow more food? Is it to enhance the nutrient content of the crop? There's something called a technology fee, that it's the royalty that the seed company that holds the patent on this genetically engineered seed collects on every bag of seed that they sell. This tech fee is above and beyond the cost of the seed. And having been in the seed business since the mid-80s, I saw these seed prices go up, but then when we started with the genetically engineered crops, they really started going up. So by 2010, I thought I'm going to do a little math on this. I presumed that if we used the latest and greatest technology on corn, soybeans, cotton, canola, sugar beets in our country, how many dollars would that generate? Now, I didn't know what canola was, so I called my neighbors to the north and got the help I needed on that. And I found out what cotton was when I started working with the farmers in southwest Georgia. I'll show you the cotton prices in a second. But doing this math, and again, I'm presuming 100% of the acres according to USDA planting rate, how many dollars will this generate per year? We didn't plan 100%, I just used that numbers to make it consistent. On corn, the tech fee was $60 an acre, and we had 87.9 million acres, so it was $5,274 million tech fee. On soybeans, we had 78.9 million acres, it's only $24 an acre tech fee, so that's just under $1.9 billion tech fee. On cotton, it's only $78 an acre tech fee, and it's only 10.9 million acres, so it's $850 million and change. As I said, I had the good fortune of working with cotton farmers starting in 2010 in Georgia, and they gave me a lot of education about cotton and the history of the cottonseed price. In 1993, a 50-pound bag cost between $45 and $60 a bag. In 2010, they no longer sell a 50-pound bag, it's 230,000 seeds per bag, and the bag weighs from 38 to 46 pounds depending on the size of the seed. The cost of the seed is $159.99 per bag. The tech fee is $412.20 per bag. The seed treatment, which is a combination of insecticide, fungicide, and pneumaticide, which you have to use. If you don't have that on the seed, you're not going to get a stand of cotton, because there's so many natural organisms and control mechanisms in the soil that have been wiped out by the way the crop is being raised. They can't get a stand without all this pesticide. So we're looking at $697.19 versus $60 a bag in that time period. Continuing on, there were no, I want to emphasize, there were no sugar beets planted genetically engineered that year because the moratorium was in place and the court order had taken them off the market. But they came back the next year and we're up in the 93 to 5 to 6 to 8% range now. Again, presuming all the acres were, it would be kicking 96 million. Canola, we don't have that much in this country, that's only 9 million. So we subtotal all these crops in the U.S. at just under $8.7 billion for 1 year. I was in Canada speaking a couple of weeks ago, and I thought they'll feel left out if I don't do the math on their canola crop. So I figured that up. It was 1.2 billion and change. So if we rough total the estimate for 1 year, presuming 100% of the acres to the latest and the greatest, based on those planting year acres, it's $9.9 billion. That's not the seed, that's not the fertilizer, that's not the chemical, that's just the technology fee. What could possibly be the motivation? We're told, and sadly so, by some who are in positions at our land-grant universities who know better, that crops have been genetically modifying themselves for many, many years. Well, that's true. There have been genetic advancements through mutations and thousands of years of natural progression in some of our crops. But this genetic engineering won't happen in nature. And for them to say that is not only not true, it would be a polite way of saying it's deceptive. How does it work? A foreign gene shot into the DNA of that plant. one or all of the following are used. They need a mechanism to promote or turn on this specific characteristic that they want in this plant, so that's called a promoter. Typically a virus will be used as the promoter. It's kind of like wiring the building, having light bulbs all in, the juice is hooked up to the fuse box, but if you don't flip the switch on, nothing's going to happen. So a virus is typically used as that promoter. The cauliflower mosaic virus is a popular one. In addition to that, they have to make sure that this characteristic or this trait is everywhere in that plant. Well, how do you tell if it's everywhere? First, you better have a mechanism to see that it's everywhere. So you genetically engineer a bacteria that is resistant to an antibiotic, and you use that as a marker mechanism to prove it's everywhere. Well, how do we get it everywhere now in that plant? Because you can put it in there, it's not going to go around by itself, because this is not a natural process. So let's use an agrobacterium, which in essence is a cancer cell of the soil. This agrobacterium and or a component of E. coli will act as the infection mechanism to get this characteristic throughout the plant. This is important that it's there when you're using a herbicide that's designed to kill everything it touches. Because let's say you only get that characteristic in the top 2/3 of the plant, you spray that chemical on there, the top survives, the bottom doesn't, what do you think is going to happen to the plant? When they register these genetically engineered crops and patent them, and give the information to the regulatory agencies, they are supposed to provide to them all of the things they use in accomplishing this task, as well as the general vicinity of where you're going to put it. European Food Safety Authority analyzed 85 different genetically engineered crops, and they found that 54 of them contained an unspecified, in some cases unknown, viruses that were not reported to the person that filed for the registration on that crop. So, did they know it was in there, or just didn't tell? That's not specified in the scientific study. This slide was given to me by a retired molecular microbiologist from Washington State University. I was up in Washington State in September giving a presentation similar to this, and I made a comment. I said, you have a 1 in 100,000 chance of getting this gene in the same place in the DNA twice. She politely raised her hand and she says, Howard, that's not true. She says, I have spent much of my career doing this the way it's utilized in crops. And she said it's not near that accurate. So she politely sent me this slide along with these statistics. You have 1 in 1 trillion to 1 in 100 trillion chance to get this in the same spot twice. Well, you're going to see why that's important. Every time they do this insertion, there's a potential development of a new foreign protein in the fruit of that plant. How does this affect mammals? First of all, did you know you're a mammal? And there's 5,400 other species, counting yourself in this little experiment that's underway. The side effects. As I said, I've had the amazing pleasure of working with family farmers, crop and livestock all across the country since 1992. In 1998, we had a customer in Nebraska, bought his first BT corn, planted enough to fill 1 grain bin, harvested that corn, put it in that grain bin, had it separate from the rest of his corn, ground a batch of feed out of that BT corn bin for his sows when he was going to breed them. Conception rate dropped 30% of what he normally saw. Thought, well, that was odd. Didn't know for sure what happened, so he ground another batch of feed out of the other bin for the next group of sows. They were right back where they belonged. You kind of like to move corn out of one bin and the other, so he took a batch of feed out of the BT bin for another batch of feed. Next time the conception rate dropped 70% on the sows, and he thought, something's not right. So he had the vet come out, do blood work, check everything, check the corn for vomitoxin, mold, and what have you. Couldn't find anything wrong. He called me and I said, we're hearing some issues with this BT. Don't use that. We go to South Dakota, different operation, another BT version of corn. They had computerized record keeping of everything they did on their farm. They weighed every kernel of grain, they weighed every pound of pig, and they counted all their numbers. When they had the BT corn in the ration for their sows, they had 1.6 pigs less per litter, and the weight of the pigs was lighter when they were born. We go to southwest Iowa. Different BT corn. Another year or two down the road, gentleman has something called pseudo-pregnancies. In essence, the sow appears to be bred. She goes through full gestation, and upon delivery, she delivers a sack of water in the afterbirth. No piglets whatsoever. Well, this gentleman this was a devastating problem, and he had the vet out, and the university got involved. How could something like this happen that had never happened before? He was a Farm Bureau member. The reporter from the Farm Bureau paper come out, the spokesman, and did a story on his plight. They published that story in the paper. He started getting phone calls. 5 farmers from the surrounding area called him up. They were having the exact same problem he was having. The vets were involved. The university was involved. The farmers get to talking. Lo and behold, they find out they're all planting and feeding, had planted and were feeding the exact same BT corn. The university couldn't find any possible connection between that BT corn and this problem. The farmers all switched to a different corn and the problem went away. In our part of Iowa, when we put the genetically engineered feedstuffs in the ration, whether it was the Roundup Ready soybean meal or the BT corn or then the Roundup Ready corn, consistently we would see ileitis, salmonella, bloody bowel, especially in the nursery pigs. We'd get them over this problem. If it had come back later after the antibiotics wore off, if one of them succumbed, do a post-mortem, the vets would consistently see irritation, inflammation, and a lot of times ulcers in the stomachs. We also saw consistency in immune system problems in the nursery pigs that were fed the BT corn, or the genetically engineered soy, or the BT Roundup Ready corn as years progressed. A lot of the pigs were anemic. The immune system. All mammals have an immune system, and 70% of your immune system is located in your digestive tract. Now, I want you to imagine that I am your immune system. I'm in your stomach, and it's my job to protect you 24/7, 365. I never sleep. I'm always on call, I'm always on duty. You eat something, and in this food you eat, an alarm goes off when I see a foreign protein enter your digestive system, which is my domain. I'm identifying this as a foreign protein. I go to work 24/7, 365. I want you to imagine that you leave here now, and you come back at this time tomorrow night, and I'm still doing my job, doing my best to get rid of this foreign protein that you have consumed. And maybe you added another meal that you added some more foreign protein that I had to work against. What will happen to my strength? Are autoimmune diseases increasing in our country? Do we have foreign proteins in 70 to 85% of the processed food in the grocery store? An autoimmune disease is when the immune system attacks the body's own tissue caused by an antigen or a foreign substance, triggering the production of antibodies when the foreign substance or invader is detected. The primary symptom is inflammation. Remember that as I start to show you some pictures. That brings me to a point in time I'm going to show you what I learned in a tour of a hog slaughter plant. I had reason to go tour the plant up the road. They do custom processing, custom harvesting for niche market pork companies. I knew of 3 or 4 different niche market programs that had their hogs processed there. There were a number of drug-free programs where the hogs were processed there. The drug-free meant they didn't feed the hog any antibiotics from the day they were born until the day they were harvested, which was a good thing. But all of these drug-free programs that went there did not have a restriction on feeding genetically engineered grain. This was in 2008. 80+% of the corn was GE in our area, 90+% of the soy was GE, so it was safe to presume that these pigs were all eating genetically engineered corn. The pictures are a little graphic. If you're squeamish, look at the first one like this, and if you don't pass out, then you watch the rest. Dr. McGuire is the veterinary that gave me the tour of the hog slaughter plant. He helped with the interpretation of these pictures. Dr. Newman is the veterinary that I had the good fortune of working for 8+ years when I got out of high school. I worked for him part-time. And he was semi-retired by this time, and he was focusing strictly on draft horses. Now remember, I said 1998 we started to see these problems with reproductive issues and digestive issues that started to cause this irritation, inflammation in the digestive tract. So if the vets that were actively practicing hog medicine in that point in time, if they were seeing this irritated and inflamed stomach over a 10-year time period, what might they start to call it? Normal? Well, Doc Newman told me it wasn't normal. This is what a healthy hog stomach looks like. Notice the overall skin tone color of that stomach. Very little sign of any irritation, inflammation. This yellow over here is normal. That will be there as a result of the stomach being empty. There's no feed to digest. The amino acids and enzymes are still active, and it produces that mucus. Excuse me. This is what the first drug-free, presumably GM fed. Notice the overall redness and irritation in that stomach. Right down here is a small pinpoint ulcer. This is another one. As you see, the overall irritation, inflammation is represented by the redness. There are no ulcers in this one. This is one of the worst ones of all of the GM-fed, drug-free pig stomachs we took a picture of. You see the intense redness. These dark spots are pinpoint ulcers. There's about a 3 to 4 centimeter ulcer over here. There's some here. They're pronounced pretty well throughout. This is the stomach of a hog that was on antibiotics the majority of its lifetime. Dr. McGuire was quick to point out the benefits of the right antibiotic at reducing irritation and inflammation. But do you see there's a healed ulcer right dead center? This is a picture of one of the worst ones of the antibiotic-fed hogs that we took pictures of. And again, that's pale. It doesn't have the healthy skin tone color, but it doesn't have the redness and irritation, but the ulcers are all over the place. I was referring to all of these happenings that were happening on family farms throughout Iowa, Nebraska, South Dakota, and some in Minnesota as circumstantial and coincidental. You have genetically engineered crops in the feed supply, you have the problem. You take it away, the problem goes away. You put it back, the problem comes back. You take it away, the problem goes away. I was working with Dr. Lane Ingham at that time on our soil microbiology program, and I told her it's circumstantial, coincidental, and she says, no, Howard, it's anecdotal. Now take it to the next level and do a scientific study. Write up the protocols and conduct a study with all the controls and see what happens. Well, the good Lord saw fit to connect me with Dr. Judy Carmen from Australia. We did just what Dr. Ingham suggested. We wrote up the protocol. We conducted the study. We had 84 pigs that went on a non-GM corn and soy diet and 84 that went on a GM corn and soy diet. We took them right off of their mama when they were weaned. We evened them up. They were all even for size. They were all even for sex. And after they were all randomized, we drew a number out of the hat to see who was going to get to eat what. The only person that knew what they got to eat was the person that put the feed in the feeder. All the people that were monitoring their daily activity and their weekly activity had no clue what was going on. When we harvested them animals at 6 months of age in essence, which is the normal age of an animal, of a pig for a meat animal, we took them to that slaughter plant up the road where I had taken the tour and got all these pictures. We took all of the innards, all of the organs except the brain out of these pigs. It was all identified. We had all their tattoos, all their numbers. Everything was completely coordinated. We took them off site, and we had 2 licensed practicing veterinaries did complete autopsies on every component and part of the anatomy of that pig, internal organs. We weighed all of the organs that could be. This is what a healthy stomach again looks like. This is what a stomach with severe inflammation looks like. The statistical findings of this study. The GM-fed pigs were 2.6 times more likely to have severe inflammation in their stomach. Of that, the males were 4 times more likely and the females were 2.2 times more likely. The weight of the utera of the GM-fed females was 25% abnormally larger than the average weight of the non-GM-fed female. You remember I said we had reproductive issues in pigs that were fed BT corn in the south, and we have digestive issues in pigs that were fed GM grain. Did we find a connection between reproductive and digestive in the body parts that we did the autopsies on? Now, 1998 was when we started to see the problems. 2013 is when this study was published. I have come to understand that it takes from 2 to 8 years to get a scientific study published from the time you know what has happened. I agree with the need for science. Coincidental, circumstantial, anecdotal, scientific. I'd like to add another term. It's called common sense. On the farm, we don't have that long to wait. The things that we saw in this study that we were not prepared for, we didn't anticipate it, so our protocol was not set up to record it and document. And you don't change horses in the middle of the stream or you get yelled at. As I said, we had to weigh these pigs every week. When they were small, we picked them up, put them on the scale. When they got bigger, we run them down the alley through a simple maze and weighed them. The people that were weighing the pigs had no idea who was eating what. There was 2 pens of pigs here, and there was 2 pens of pigs here. When they ran these 2 pens through the simple maze to weigh them, it always took less time. They almost lined up. You know, pigs are creatures of habit. They can figure this out. When they did these 2 pens, they couldn't figure it out. And as soon as you got them in an environment where you were in confined quarters, they started fighting, biting, and picking on one another. When they're back in their normal surroundings, listlessness or a lack of contentment. In these 2 pens, it took longer to get through this simple maze. Now I got a question. Have we seen between 1995 and today a change in the behavior of the children and the young adults and even some of the adults in our country? With the fundamental change that has occurred to the food supply without anybody's knowledge by the insertion of foreign proteins in the form of genetically engineered crops. In addition to this, we saw some anecdotal issues with eczema. We were not allowed to mention any of this in the publishment of that paper. From a scientific standpoint, it probably doesn't exist. I'm not a scientist. Here's a simple maze. Gate comes down here, we swing it around, it's kind of a circle corral. All they got to do is walk down that simple alleyway, jump on the scale. Shifting gears, going to Ohio. A friend of mine there butchers his own beef on the farm. On the left you see he only raises non-GMO. He also butchers for the neighbor on request. They have to come in and help. He doesn't do it for hire because he's not inspected, and that's legal. If you can help one another, you can do that. They say that if you consume a toxin, it will accumulate in the fat tissue in the body. Which one do you think is cleaner and has less toxin, and which one do you think has more toxin? The non-GM or the GM? Glyphosate is the active chemical and ingredient in Roundup herbicide. It is the most widely used herbicide in the world. It was estimated last year there were 880 million pounds used worldwide. Roundup was patented in 1974, the patent went off in 1996, and when that happened there were lots of generic forms of glyphosate-based herbicide introduced. In 1974, when it first came on the market, it was used primarily as a burn-down herbicide. That meant, here's a field that has some grass and weeds growing in it, I'm going to spray it dead, and I'm going to no-till farm it, Spraying it dead was a good thing because I didn't have to lose moisture in a drought. Didn't have to worry about soil erosion. I come in and plant. Now we progress forward to 1996. The crop's genetically engineered to tolerate this chemical that's designed to kill everything it touches. And then we put on more glyphosate. But did you know, about 8 years ago, give or take a year or two, the makers of this product started to promote another use for it. Use it as a desiccant or a ripening agent on a crop. Say your small grain, oats, wheat, barley, rye, is about ready but not quite there, and your question is the weather going to be in my favor or against me. You go out and spray this glyphosate herbicide on that crop, 5 to 8 days later you can go harvest it, it's dried down. Or say you have edible peas that you want to harvest them all at the same time. Go out and spray it with glyphosate, dry it down, you can come and harvest it. Or say you pick cantaloupe for a couple pickings and you're tired of waiting for the rest of them to get ripe, so you come out and you put that on there and you kill them and come back 5 to 8 days and you pick the rest of the cantaloupe because they turn color. Or say you're raising sugar cane, you put it on 8 weeks ahead of when you're going to harvest. All the leaves will fall off, now you don't have to burn them off, so now the hand laborers can come through and chop that cane plant off and you can harvest the stalks. That's been the case in Guatemala. Dr. Huber's been working down there for a year plus now. First time he went down there, they were trying to figure out what they had to do to get the health back in their cane crop because it was not performing like it used to. Well, he asked questions. Well, they started using this desiccant. Well, the third trip down there, they made the comment, 1 in 4 of our cane field workers is dying per year to renal kidney failure. So being the good epidemiologist that he is, asked the question, when did this start happening? Same time they started using this product as a desiccant. They no longer use it in the fields that he's working with. What happens to that chemical residue when you spray that on that crop that's about ready to harvest? Where does it go? 20% of it is going to go into the soil. The rest is going to be in the grain and the stalk. Glyphosate is a very strong chelator. Chelate is a Greek word meaning claw or to hold. If you chelate something, you tie it up. Glyphosate's a strong chelator. Chelates calcium, magnesium, manganese, zinc, iron, copper, nickel, cobalt, boron, selenium, molybdenum, and potassium. It will chelate these minerals in different forms in different environments, but wherever the glyphosate is present, whether it's in the soil, whether it's in the plant, or whether it's in the grain that's harvested, if it's present, it's going to chelate those minerals. In addition to that, glyphosate is a very effective biocide. A biocide is in essence an antibiotic. The biocidal effects of the glyphosate in the soil, when that herbicide goes through that plant into the soil, it has an adverse effect on the beneficial organisms in the soil. Dr. Kramer has numerous scientific studies. Dr. Kramer is a USDA ag research scientist that has many publications on this subject. In essence, to simplify it, you're killing the good bugs, which in many cases are the control mechanism for some of the bad soil disease-causing organisms, in addition to killing the controls, which allows the bad ones to increase. It also acts as a food source for some of the bad ones, so they even increase more and increase faster and become more virulent as they increase. Now, this was denied by the manufacturer for quite a few years, but in 2010, the U.S. Patent Office granted a patent to Monsanto on glyphosate as an antibiotic. You go on the website and you read this, patent number 777-1736. It will be listed as a parasite control. Well, a parasite's just a higher version of an organism. You read on down through that, and you get down to the bottom, and you see at 1/10 of a part per million inclusion level, glyphosate is very effective at killing the vast majority of the good bugs you want in your digestive tract. Them good bugs also have to be in other mammals' digestive tracts, and I'll show you some information shortly about that. This is a published scientific study conducted by Dr. Kramer and Luis Zobioli. They took a glyphosate-resistant soybean, and the original conventional isoline of it, they grew them side by side in the greenhouse. They put the glyphosate on, the glyphosate resistant one, and sequential half rates, and at the full rate. The top left, you see the lignin content in the plant drop significantly. The top right, you see the sugar or photosynthesis capabilities of production of that plant drop significantly. The bottom left, you see the amino acid production capability of that plant drop significantly. The amino acid composition, the enzymes in the amino acids, that's the defense mechanism of that plant. You have an immune system, the plant doesn't. It has a defense mechanism. In essence, if the plant had an immune system, you could say when you spray it with glyphosate, you're going to give it a bad case of AIDS, unless it's genetically engineered to withstand it. This bottom right corner, now remember, these are genetically engineered. That's not a weed. All of these natural functions drop when you put the glyphosate on. The bottom right corner is the water use efficiency. It took more than twice as much water to raise the same amount of plant biomass when you had the glyphosate tolerant gene in the plant and you sprayed it with glyphosate. Is water efficiency important to a farmer for crop production? Is the lignin content or the woody component of the plant important when the wind blows? 50-mile-an-hour wind the night before this picture was taken. The glyphosate tolerant corn fell down and the one standing right beside it that was conventional stood up. This is a partial list of diseases that are scientifically documented to increase in an environment where glyphosate is used. Everything from apples to wheat. There's a study in Canada that was published that shows you put glyphosate on a field 1 year of the previous 3 years before you, in a 3-year time period before you sow that to wheat, and you have 150+% increase of having take-all, head scab, and or root rot. Those are plant diseases that cause mold and mycotoxin production and disease in the plant. What happens when you have mold and mycotoxin in with the plant? Where does that mold and mycotoxin go? That grain. This is a picture of cornfields in Iowa in 2010. As you can see, most of the cornfields in that picture are brown. That picture was taken in the end of August. The corn is supposed to look like that one in the middle that's green. It shouldn't turn brown until sometime in October, unless we have an early frost. There's so much damage to the beneficial organisms in the soil and so much promotion of the opportunistic organisms that cause the diseases, you can't put the fungicides on quick enough. This wasn't necessarily as much of a fungicide problem as it was a bacterial infection. Now we have bacterial infections that are taking the corn crop, and guess what? How do you stop a bacterial infection with an antibiotic? Guess what? You can't put an antibiotic on a corn crop. Goss wilt, a bacterial infection. There's a study been conducted, 2 of them in fact, and they'll never be published, that shows that both glyphosate and the surfactant that's in with the glyphosate in the formulation of Roundup wipe out the plant's natural defense mechanisms against the Goss wilt infection. But those studies will never be published because it's financial suicide for the researcher that did the research. We also have weeds that are developing resistance to glyphosate. Over 24 worldwide. I don't know if they're necessarily resistant. They may just be turning into super weeds. This is a picture of the amaranth pigweed in the southeast U.S. Picture was taken in Georgia. There is some corn in there. Gentleman sent me that picture. He had a problem with the germination on the corn in that field. He sent me that picture and I said, there was a whole lot to that story, and for the sake of time I'll just explain a little bit. You cannot put enough glyphosate on that weed to kill it. When it's 2 inches tall, it's going to look like you fertilized it. You put a gallon on instead of 32 ounces, you're not going to touch it. When it grows up, it gets to be a big dude. It used to be 3 foot tall when it was full grown, have 100,000 seeds on it. Now it's 10 to 12 feet tall and it has 400,000 seeds on it, 400 to 500. Because of the mode of action and the function of how glyphosate kills a weed, you are continually going to develop a super weed with every weed that gets around it. and because it's increasing the virulence of the diseases that are actually responsible for killing the weed, this accelerates that process. They're talking about coming out with 2,4-D resistant corn in addition to glyphosate. 2,4-D, this weed will laugh at it. You can put, the cotton and the peanut farmers in southwest Georgia can put 8 chemicals in the tank and spray that field when that weed's that tall. You can't touch it. You know what happens if you put a jug of 2,4-D in the back of your pickup and take the lid off of it and drive down the road in southwest Georgia? You'll probably kill half of the cotton fields in the neighborhood because they're so susceptible to drift of that chemical. You know what happens to 2,4-D when it gets, your flowers get a whiff of it or your tomato plants get a whiff of it? Do you know that if you use 2,4-D or dicamba herbicide that you can spray it today, it's a nice beautiful day and everything lays down nice and easy and it's wonderful weather and you've got just what you needed to put this on. The next day comes, the next night it heats up. When you get hot and humid, guess what happens to that 2,4-D in Vanville? It gets up and it moves and it goes for a walk. It sets down on your flower bed, it sets down on your tomato plants. Tall water hemp, first cousin to the amaranth pigweed. This is in Iowa. Sprayed 3 times with a rate of Roundup. He wouldn't even tell me how much he used. And it has to, it grows up. You could call it a superweed as well. The glyphosate residue. Paul Capel and his team of U.S. Geological Survey scientists set up monitoring equipment in Iowa and Mississippi in 2010 and 2011. They found significant levels of glyphosate in the air, in the rain, and in the rivers. We have found glyphosate residue in all of this and more. In the alfalfa, it was not in glyphosate-tolerant alfalfa. It was detected in the dry hay that was harvested from a conventional hay field before glyphosate-tolerant alfalfa was even put on the market. The glyphosate residue came in the manure that was used as fertilizer to fertilize the alfalfa. We are finding glyphosate residue in virtually all of the manure that we have tested that comes from a confined animal feeding operation that's using glyphosate-produced corn and or soybeans in the feeding of those animals. In 1994, the EPA said 2 parts per million per day per life wouldn't hurt you. Last year, on the 1st of May, they raised the tolerance levels for everything they had a glyphosate tolerance for. According to the public record, when you go on the website, you will see they received a letter requesting the increase in these tolerance levels from a company in St. Louis. There was no accompanying scientific data to document the fact that this was a safe and good idea to increase this. It was just a request. 400 parts per million in forages which are fed to animals and as high as 40 parts per million in some grain. Google this. Check it out. See what the levels are in the carrots and the onions and the different food crops. There's a glyphosate tolerance level in every one of them. 1997, it was 1/10 of a part per million in soy. They raised it to 20. We routinely see 5 to 10 parts per million. Last year they did a random sampling in Argentina. A scientist collected 11 samples right at harvest. It was all glyphosate tolerant soy. 7 of the 11 were above the 20 national standard tolerance level that's permitted, and some was as high as 90 parts per million. You might say, why? What difference does this make? Seralini is a French scientist that does numerous excellent studies that have been published in scientific journals that document the damage that glyphosate causes. At 1/2 part per million, you have complete infertility, killing both the sperm and the egg. At 2 parts per million, 2/10 of a part per million, you can have endocrine disruption. Endocrine disruption to a fetus in the womb spells some form of birth defect. Endocrine disruption to an adult, did you know you have cells that die and rejuvenate in your body every single day? An endocrine disruptor gets in your system, it causes the formation of abnormal cells. What's a cluster of abnormal cells called? Dr. Andres Carrasco from South America was seeing significant increase in the birth defects to the babies that were being born to the mothers that lived in the soybean fields or lived adjacent to the soybean fields that were being sprayed with glyphosate herbicide with an airplane. So he did a study on frog and chick embryos, and he exposed them to varying levels of glyphosate. At 2.03 parts per million, there was consistent birth defects, facial cranial deformations, and more. The ruptured purpura, as you see on the lower left-hand corner, 447% increase in the birth defects between 1998 and 2008 to the babies that are born in these areas. What's going on in the Yakima Valley? Last year there was a report by the State Health Association about the birth defects in the Yakima Valley river bottom. A drastic percentage increase in the encephalopathy. If a baby's born with that disease, it's a brain disorder. If they're born alive, they don't live more than a matter of hours. You research the records a little bit, and you'll find in the last 15 years, the only herbicide they've allowed to use for weed control in that Yakima River Valley has been glyphosate herbicide. But the State Health Department hasn't made that connection. Glyphosate's chelating ability ties up calcium, which could affect teeth and bones, ties up iron, which could affect the blood, ties up manganese and zinc, which could affect the liver and the kidney, ties up copper and magnesium, which could affect the brain. When the conductivity of the tissue in the brain deteriorates, you have dementia, Parkinson's, and Alzheimer's. Are any of those diseases on the increase in our country? This is a picture of a stillborn baby calf. Dr. Art Dunham is an excellent large animal veterinarian in northeast Iowa. In 2004, he started to see things that made no sense whatsoever in the large animal that his farming customers, and as he learned to realize the farming customers that were using glyphosate herbicide were experiencing. There'd be an animal here in the morning, looked as healthy as he could be and was dead as a stone at night, or vice versa, healthy at night, dead in the morning. He did his job as a good vet. He took a sample of that liver and he sent it to Iowa State University for a full mineral analysis. That mineral analysis indicated a severe deficiency in manganese and other micronutrients. If you don't have enough manganese in the liver cannot expel the toxin from the body. This part of Iowa, they always had to make sure they never put additional manganese in the ration for their animals. There were such naturally high levels in the soil. If you added any additional, you'd have manganese toxicity to your animals. Remember, glyphosate chelates minerals in the soil, in the plant, and in the grain. Why do these animals have 10, 15, or at most 20% of normal levels of manganese in the liver after they die? Dr. Nancy Swanson's a PhD researcher from Washington State University. She's retired. She also served in our Navy. Last year she published an article. She did some research with another individual. She looked at, is there a correlation between the introduction of the genetically engineered crops in our country and the subsequent use of glyphosate herbicide? Starting in 1996 over to 2012, we see the increase of GE corn and GE soy and GE cotton and GE corn and soy. Now I want to tell you, there's absolutely no cause and effect in these examples I'm going to show you. I'm not going to show you all of them. You can go to the Moms Across America website and look at all of these different illnesses and increases, incidents in disease that have been documented by the CDC in our country. There's no reason for cause or effect, just based on what she has analyzed. But if you look at the Samsel-Senef paper that was published last year, that was a complete review of the scientific literature and looked at the possible connection between what scientific literature said about the toxicity of glyphosate and how it could directly affect how many different diseases in our country, you would see not only the strong correlation, but more. This Pearson correlation coefficient, is there a trend, in essence, between the use of glyphosate herbicide and, in this case, the increase in autism. We come up to 2009. The correlation is 98.5%. Here's 1996, where it kind of starts going up there. We're at 2014. Where's that line at now? Dr. Stephanie Seneff has done a lot of research on autism, published several papers on the subject. In 2007, 1 in 150 children in our country had it. By 2009, it was 1 in 100. By 2013, it's 1 in 50. In boys, it's 1 in 29. If something doesn't change, by 2020, 1 in 2 children in our country will have autism. Here's diabetes. Again, 98% correlation. The green line is the trend line. Starting at 1980, we should be right here at 2009 if the trend would have continued. But here's 1996, the introduction of genetically engineered crops and the use of glyphosate herbicide. Again, this does not suggest cause and effect, but it is a wake-up call and a warning call for the CDC. Why do you not initiate an all-out, full-fledged investigation in the epidemic increase in these? And these charts, those first 13 or whatever it was I showed you, they're all in the same range. They're 98, many of them 98% correlation between the use of this technology and the increased use of this herbicide and the increased incidence of this disease. This is thyroid cancer. Again, the green line's a trend line. That's where we should be. 1996. Where does it start going up? Now we're going to go to Germany for a second. Dr. Monica Kruger is an excellent veterinary pathologist at Leipzig University. She's only going to be there until the 31st of March. Her contract has not been removed or renewed. There's been a significant amount of pressure applied to the university to not renew her contract because she has consistently documented a correlation between glyphosate toxicity at 1/10 of a part per million in the feedstuff and damage to numerous microorganisms in the digestive tract. The beneficial microorganisms. You can go to the EPA's website and look at that patent 7771736 and see it documents the damage of these specific microorganisms in the digestive tract. Dr. Kruger is documenting the same diseases in chickens and in cattle. Kill 3 good organisms in the digestive tract. In chickens, see the E. coli go through the roof. Kill 3 good organisms in cattle, see the Clostridium botulinum organism go unchecked. Clostridium botulinum causes toxic co-infection or botulism. Now, this is acute, this is chronic. Chronic happens about 5 to 8 days. You can't believe how fast these animals will go downhill. Acute, they're going to die quicker than that. I've done this presentation in different parts of the country where there's dairy and the farmer in the room will raise his hand and he says, if that's true, every one of my cows should be dead because I'm feeding Roundup Ready corn and Roundup Ready alfalfa. I said, hope and pray that you don't have the same environmental conditions they do in Germany or your words may come true. Dr. Michael McNeil was out in the New England states giving a presentation about this problem in crops and livestock. There was a dairy farmer in the back of the room. At the end of the meeting, he come up to Dr. McNeil and he says, we're losing cows, and some of them are just dropping dead with no clinical signs. We can't figure it out. The vets don't know what to do. Would you come to my place and look at my cows? So Dr. McNeil went there the next day. They're in the barn. They're looking at the cows. One cow walks up to the water tank, takes a drink from the water tank, walks away from the water tank, and as she walks away, she drops dead on the spot. The farmer started to cry. Dr. McNeil didn't know what to do. The farmer then went on to explain that his grandson was in the hospital, failing fast, and nobody knew what to do to save him. Dr. McNeil was in Fort Detrick in the military and worked in the infectious disease department when he served our country. He asked the man the symptoms of the child. He explained them to him. Dr. McNeil recognized it as chronic botulism. He said, you get in that vehicle and you drive to that hospital right now and you tell them doctors test that child for botulism. They did. It was positive. They administered the proper probiotic. They thankfully saved the child. We are hearing about the workers milking the cows, and some of these cows dropping dead for no reason but the workers that milk these cow herds where these incidents are happening. I've heard it from my friend in Denmark. The workers don't want to go to this one farmer's place and milk cows no more because the workers get sick when they go there. We've heard about it in Northeast Iowa. We're hearing it in all parts of the country. The botulism is not as severe as it is in Germany, but it's absolutely here. And it's here where they're feeding feedstuffs that have been raised in a Roundup Ready production system. 10 to 20% of the babies in our country that die to sudden infant death syndrome test positive for the Clostridium botulinum organism. In 2011, in January, Dr. Huber sent a letter to Secretary of Agriculture Vilsack. It was a confidential letter. He never intended for it to go public. He did not know nor consent to it being made public. He don't know how it went public. There's a rumor that that it got leaked through a channel in USDA, but nobody knows how that happened. This letter had the subject about warning the Secretary of Agriculture, and Dr. Huber's certainly someone that should be in a position to do that, having 41 plus years service to our military and being on the infectious disease task force and panels and head of the APS committee. The man has credentials that are impeccable. He said, "Mr. Secretary, there's a problem out here in production agriculture that's been brought to my attention that there is a new to science, unknown agent." At that time it was identified as a suspect fungal mycelium abortogenic agent is what we refer to it today because it causes spontaneous abortions in beef and dairy herds where it's found to be present in horses, in hogs. It'll kill a fertilized chick embryo in 24 to 48 hours. It's been found in sheep and goats. It's also been identified in miscarriages in women. The reason for the letter was number one, we need help. USDA has all of the equipment and all of the manpower and all of the resources to come in and figure this thing out now. They didn't help. The other reason for concern was the incidence of these things happening was wherever there's glyphosate produced food crops, the incidence is the highest. Dr. Huber made the most courageous act that anyone could ever make with a stellar professional career in a scientific arena and in the military service. He threw it all on the line because the Secretary of Agriculture refused to not deregulate Roundup Ready alfalfa and sugar beets and put more of this toxin in the environment. And he's been criticized and ridiculed by people that have no clue what was all going on. After this letter was released, he got a communique from the Chinese scientists. And they said they sprouted some Roundup Ready soybeans they imported from the United States that were shriveled. They sprouted them, they grew them up, they cut the leaf on the plant after it grew up, they put the sap under a microscope. They sent him pictures that looked identical to this abortogenic agent. They're identifying it as an unknown protein. We're getting closer to figuring out what it is. And Dr. Huber is not the person that found it. It's someone else whose identity will remain completely anonymous, because if anybody found out where that gentleman was at, he'd be gone. And then where would we be? Dr. Huber became a moving target for the benefit of mankind on this issue. He laid his whole career on the line to try and save our country. What do you see in this picture? This is a combine harvesting glyphosate tolerant, genetically engineered triple stack corn. We have noticed a high increase in the incidence of this dust. Remember I said how the glyphosate kills the beneficial organisms, it allows the opportunistic to increase, the opportunistic increase More plant disease, more dust, more mold, more mycotoxin. Well, the gentleman noticed this and he thought, I'm going to take some samples. So his dad had Roundup Ready corn, cleaned off a spot on the combine, collected the dust sample at the end of the day, marked it. Did the same thing with the Liberty Link corn, cleaned off a spot in the morning, went back to that spot at night, collected that sample. Then he saw some dust in his hog building. He collected a sample of that, sent it to Midwest Labs for a mold and, mycotoxin count. The lab sent the results and they said, warning, anybody working in an environment where there's over 1,000 CFUs per gram needs to have a protective breathing device on. The hog dust was 14,000 CFUs per gram, 1,000 Aspergillus niger, 10,000 Aspergillus species other, and 3,000 penicillium. Liberty Link corn was 7,200,000, 700,000 Aspergillus, and 200,000 penicillium. The Roundup Ready corn dust was 15,600,000, it was all Aspergillus species. There's absolutely nothing scientific about this. I urge all farmers to wear one of these when they are handling any genetically engineered grain. Why do I bring this up? Well, I have tried to get people at the university, one of the universities in a state in the Midwest, to do a test on this issue as far as dust. And I've been unsuccessful. For some reason it's a hot potato. Nobody wants to touch it. But what's happening from a common sense standpoint? If somebody doesn't have that dust mask on, they have a respiratory ailment that won't go away, or they end up with pneumonia, or the people that live in the small communities surrounding the fields as they're harvested in the fall that are predominantly Roundup Ready corn and Roundup Ready or Liberty Link soy, where's the dust go? Why is there such a dramatic increase in the incidence of respiratory disease to the people that are not farmers? They live in town. It's not scientific, but it might be common sense. This is an interactive slide. I need you to participate with me in this. Do you recognize any of the names in the center of the circle? Have you ever seen a commercial on TV that says, if you can't afford your medication cost, contact us, we have a program to assist you? That commercial sponsored by AstraZeneca. Have you ever heard of atrazine? One of the oldest herbicides used in corn production, made by AstraZeneca, Syngenta, also the manufacturers of genetically engineered seed. When you see or hear Bayer, what's the first thing you think of? You ever heard of Bayer Crop Science, the makers of Aztec Insecticide, Liberty Herbicide, and genetically engineered crops? When you see or hear Pfizer Pharmacia Upjohn, what do you think of? Pharmaceuticals. Did you know that they were the sole parent company of Monsanto at one point in time and they're still connected in a fashion? We've established the fact that all these companies in the center of the circle are in the chemical and the pharmaceutical business. Let's start with chemical. I would like you to give me one word that you might use to describe a chemical which would kill a weed or an insect, and you're describing this chemical to a 5-year-old child. What one word might you use?
Poison.
Okay, we're putting poison on crops. What do we raise crops for? Cereal and grain. What do we feed the bulk of the grain to? If there were to be any residual effect of using this poison in crop production, do you think it would have a positive or a negative residual effect?
Negative.
If it's negative and you feed the grain to the livestock don't feel good, who do you call? When the vet comes and looks at your livestock, what might he suggest you give them to make them feel better? What if you want them to grow faster so you can lower your cost of production and be more efficient in raising your livestock? What might you give them? What do we raise livestock for? If there's a residual effect of this poison that's used on crops, it could affect the grain, it might affect the livestock. Is there a chance it could affect the meat? Who eats the meat? If the people eat the meat and they don't feel good, where do they go? after you eat, or after you go to the doctor, where might he send you with a piece of paper with his autograph on it? Does that present a positive cash flow for the company in the center of the circle? There are foreign proteins that are indigestible with potential allergenic effects, crops deficient of nutrient content because of the chelating effects of glyphosate, increases in the growth of opportunistic fungi causing plant and animal disease, increased environmental challenges such as dust, increase in mold and mycotoxins, increased need for antibiotics, increased immune system challenges and inflammation and disease, and respiratory problems. I will repeat what I said earlier. I am privileged to work with some of the top scientists from around the world in researching and solving problems that we are documenting and manifesting in this absolutely total change in our food production system in our country. And we believe in the technology itself because it's been demonstrated very well in the production of insulin. Because of genetic engineering and perfecting the process, today we have a much more constant, safe, effective supply of insulin. But they controlled it, they fine-tuned it, they perfected it, they did away with the side effects. Can we say that's been done in crop production? Do you want your family eating this? What can you do?
Yes, on 15-1.
I was given this picture by a friend in Southern California. She found this sign posted on the schoolyard where her kids go to school. Now this is a very reasonable lady. She believes in protecting her children. That sign no longer gets posted on the schoolyard where her kids go to school. And I'm not going to say that the first time she went and had a conversation about that happened, but you might describe her as a mama bear when it comes to protecting her children. I want to ask a question. Has anybody ever gone to one of them there big box stores and walked down the aisle and you find this jug and it's got a hose squirter thing coming out of the top and it's a nice pretty white jug, and you pick it up, you take it up there and you pay for it and you take it home, and there's a weed growing in the crack of the sidewalk, and you walk up that jug and you go psst. You squirt that weed and you come back 3 days later, it's dead. Has anybody ever done that with one of them there jugs from a big box store? Okay. What happens? What happens to that when you go psst and you miss the leaf of the weed and the rest of that falls in the cement? What happens to that when it rains? I got an idea for you. My mother had this teapot set on the stove all the time. She'd fill that up with water, turn the burner on high, set it on there, and as soon as that teapot would whistle, she'd pick it up, take it off there, go outside, be careful she didn't spill it on herself. She'd put that boiling hot water on them weeds. If she needed more, she'd go fill it up and set it there again, and she'd come back. She'd pull them out just like this. They had no resistance whatsoever. They were real cooperative. And as far as I could tell, there was no ill effects of that hot water when it ran downstream. If you would like to further your understanding of this complex fundamental change in our food supply, I have some suggested reading material here. There's a number of these slides, so if you want to write it down, you're welcome to do that. This book by William Engvall is entitled The Seeds of Destruction. Very well referenced and an overall interesting view and perspective of genetic engineered crops. Another one. I haven't read this one yet. It's by Claire Hope Cummings. I heard her interviewed on a radio program out of Missouri the other day, and I was really impressed by the interview, so I decided to add it into the suggested reading. This one is entitled Our Stolen Future by Theo Coburn. I was given my first copy of this in December of 2011. Dr. Huber and I were at a conference in Canada. He had just returned home from a 5 or 7 country speaking tour in Germany and the European Union. And he met a friend of mine in the UK, which I actually haven't met yet. And my friend gave Dr. Huber this book. Dr. Huber read it on the way home, and then Dr. Huber gave it to me. It talks about the endocrine disrupting capabilities of synthetic chemicals, DDT, PCBs, dioxin, and stilbestrol. I refer to this one as mandatory reading for anyone who's thinking about bringing a child into the world. As you saw earlier in the presentation, the endocrine disrupting capabilities of the synthetic chemicals can have dire effects on a child. That fetus that's very sensitive in the womb. This is Dr. Art Dunham's daughter wrote this one, entitled America's Two-Headed Pig. It's very interesting about how it looks at production agriculture, the way it went, the way it could have gone as far as crop and food production. And the last one is The Unhealthy Truth by Robin O'Brien. A mother of 4 who saw one of her young children have an anaphylactic food shock reaction at the breakfast table on Saturday morning. Why should food make children sick? The TPP, if you don't know about it, is something that's being secretly negotiated by the man at the top in this country along with some helpers of his. We don't know a lot about it, but what we know don't look good. In essence, it's going to hand away the sovereignty of our country to a multinational controlled world tribunal court. That's what's been leaked out. We don't know, again, what is in it. Why does it have to be negotiated in secret? And if it happens, will we be able to say anything about what we can do and control and protect the food supply in our country, our state, our county, our city? If you would like to call a number in Washington, D.C., I have a number I can give you. It's the switchboard number. You call 202-224-3121. And that's the number, the switchboard that you can ask for your state representative or your senator. And you can tell them what you think about this.
Say it again.
202-224-3121. If you think it's a good idea, don't call them. If you don't think it's a good idea, maybe it'd be a good idea to let them know. I'd like to end this presentation on a bit of a lighter note. We had this picture sent, Dr. Huber received this picture from Gilbert Hostetler. The gentleman raises conventional seed corn. He had the circumstance that he put ears of corn in the warehouse in this old feed sack. You could see above how he found them. And side by side they sat there. And I showed this picture in Ohio at a presentation. A friend of mine went home and he did his own experiment. He put a conventional ear of corn on a nail on a tree, and then he put a genetically engineered ear of corn on that tree. And 9 months later, he took this picture. I have a question. What do the mice and the squirrels know that the scientists don't know? This is a picture that was taken from an airplane in Iowa in 2012 in the drought. This gravel road separates this field from this field. This is a river bottom. The ground is basically, well, actually it's better ground here than it is up here on the hill. This is non-GMO corn that was raised in a biological crop production. That system, that crop has been on that farm has been on a biological production system for many, many years. For the last 15 years or so, this farm has been on genetically engineered crops and controlled with glyphosate. I was told the appraised yield on that field was 28 bushels per acre, and it was chopped for silage. The yield on this field, they settled with federal crop after they harvested it for grain at 109. Now, there could be a simple reason why this happened. It rained more on this side of the road than it did on this side. But if you go over on, you imagine this field goes over to about here and you jump the fence, or say it goes to here, you jump the fence, there's another cornfield that looked like this. It was appraised at 27 bushels an acre chopped for silage. And you come down this direction and you jump the railroad track and another fence, and there was another field of corn that was genetically engineered and sprayed with glyphosate and appraised at 12 bushel an acre chopped for silage. So you got 12, 27, 28, and 9. That was in the extreme drought. You remember any point, place, and time in this presentation where it talked about the moisture use deficiency of a genetically engineered crop sprayed with glyphosate? I have the privilege of working with a lot of good scientists. We're constantly and always challenged to come up with the funding that we need for research to do the research that's so desperately needed. If any of you are inclined in any way to want to contribute, send me an email. I'll email you a form. You can fill it out, make a check out, send it right to the address in that form. It goes into a 5013C, 100% deductibility on your taxes for that donation if you're so inclined to do so. If we appreciate it. If you don't want to, that's fine, all right. Now, this is my final, just about my final slide. This lovely young lady is a new friend. I've only known her for about a month and a half. Worked on a special project with her with a delegation of people from China. She was our interpreter. She's an associate PhD professor at North Cal Polytech University in California. And she was diagnosed with stomach cancer, and I'd sure appreciate it if you would be praying for her as time goes forward. Just a lovely young lady. And I would also ask that you pray for my sister, because she's been diagnosed with breast cancer in the last week's time. Questions? And I think Pam's going to go around with the microphone so that we can, you got to hold the button in for a little bit before the light will come on.
Is it on now?
There we go.
Hi. So before everyone leaves, I have a couple of announcements. Jackson, GMO-free Jackson, desperately needs, remember I was saying it isn't always convenient to be an activist. We need your help. They need your help in donating, because it's about us. We are creating this, we're creating, and I don't see any state boundaries in this issue. So I'm just as much a part of this as everybody else is. So please donate, give of your money freely to make sure that your county will become GMO free. Also, Howard has been traveling now for almost, well, by the time he leaves California, we'll have been traveling for almost 3 weeks. He is donating his time, but we are asking for help with his travel expenses. And if you could give to that, that would be great. Any extra money will go towards research, the research fund, and or other GMO related things. That basket will be right over there.
Right here to pass
and to give to GMO Free Jackson, you will have an envelope where you'll have to fill out your information for. Is that pretty much okay? Yeah. Anyway, so moving on to the question part, I will be your GMO comment Nazi fairy. I am going to ask that people please, because it is pretty late, that if you have a question, Howard would love to answer it, but please confine it to a question and not another talk. That I will politely remind you of that task if you decide you want to give your perspective on things for a little too long for the crowd. So who has a question? Yes.
If 7 or 80% of the corn and soy is GMO in the United States, and that's what animals eat, cows and such, wouldn't they all be affected at this time?
The thing that we've seen happen is the increased use and need for antibiotics. And it happened in such a broad-scale fashion that nobody really recognized it. Now, I've been privileged to work with a number of operations that are open-minded to listening to how to improve their operation. And one, for example, sizable livestock operation, cattle, hogs, and turkeys. convinced them that they should go to non-GMO corn. They started first in part of the ration, they put their sows on it. As they started to see improvements in their pig production, then they put their nursery pigs on it, then they put their nursery turkey, the young turkeys on it. And when they started to see the improvements, I said, the only way you can know that this is for real is you have to switch back. And they just kind of looked at me like I had fell and hit my head. And a year and a half after they had this started, and they had switched their entire farming operation back to non-GMO corn. And I made that comment again. I was there, and the boss was there, and I says, you really need to switch back. And he looked at me and he says, Howard, I want to tell you something. We know our costs, and we know our bottom line. And we know how much less drugs we buy. We know how much less death loss we have. We know how much better our production of our livestock is. And I'll tell you what that number is. It's $250,000 a year more in our bank account because we went back to non-GMO corn, and we've not seen our yields suffer either. Now, you make out a check for $250,000, we'll do you a little experiment, is what he told me. Another operation that listened, they switched part of their operation over. They called me right after they switched. They said, you don't know we listened to you, but we listened to you, and we switched to non-GMO corn. We completely revamped our feed mill. This operation had so much records. They knew how many man hours they spent a day giving shots to the pigs. They know how many cc's of antibiotics they used. They knew rate again, egg feed intake, everything they knew about their pigs. The day after they put the non-GMO corn in the pig feeder in the nursery, their antibiotic use dropped 85%. They will not go back. And I'll tell you that a lot of production agriculture in corn and soybeans is going back to non-GMO for one very simple reason: economics. It doesn't pay to grow the others. There's a lot of them that are hanging on and will hang on because they farm too much, they think, to manage the operation the way it used to be. But between the sheer economics and then in the premium sow that are offered, you can get as much as 80 cents a bushel premium for the corn if you're on the river market, as much as $3 a bushel premium on soybeans, depending on where you are and what kind of soybean it is. So the economics are forcing a change.
I know you put a graph up there that said, when it talked about the dust, that you said that 1,000 parts per million was unacceptable on
No.
any of those, right?
1,000 CFUs per gram, the lab said, warning, anybody working in an environment where it's over 1,000 CFUs per gram should have a protected breathing device on.
For any one of those.
Right.
And some of them were 17 million.
No, the highest one was 15,600,000.
Wow.
Yes.
I was interested if you personally have done any research on the collapse of bee colonies since this GMO has become so prevalent.
I personally have not, but I can tell you about an excellent study that was done by a junior in high school in Missouri. And this is an unpublished study. One of my scientist friends in Hawaii is actually trying to see if it can be published. But they documented the fact that glyphosate was playing a significant role in the reduction of the bee population. And we know today, we can connect the dots. The lactobacillus bacteria, that is a beneficial bug in the digestive tract of many mammals, will be wiped out by 1/10 of a part per million glyphosate present. So in essence, that bee's going to starve to death because it don't have the good bugs in its digestive system to process the food it takes in. The neonicotinoids, there is scientific papers that have been published that connect their use to colony collapse disorder as well, both abroad and in this country.
So my question would be that, given that, I mean, it's looking pretty conclusive, especially with these different studies that have been done, and with the farmers paying so much attention to their profit margins, why is it that they're not switching over to non-GMO crops? Is it a subsidy type of thing that's going on, or what is the motivation that keeps companies going with GMO as opposed to just dropping it entirely?
Well, they're the farmers that have the sharpest pencil are switching, and at a significant rate. I don't know if they're keeping the numbers as far as percentage accurately or not. There's no question that the pendulum is on the way back in corn and soy. It's more and more obvious, and anybody that's channeling their crops into livestock, and again, there's only one study that's ever been published on livestock feeding it conventional and GM corn and soy, and I showed you that. And of course, I can tell you also that it was quickly identified as junk science by all of the pro PhD researchers that have a conflict of interest, either ideologically and or financially, because of the GM influence.
Hi, I'd like to know your tour schedule so that I can send people that I know in California to it.
You got to ask somebody else that, because I don't know. I just go where they tell me to and get up and talk as long as I'm supposed to, and sometimes I usually talk too long.
Yeah, it's a true story, but we all love it. So everyone can go to labelgmos.org and find the public events that are both in Oregon and the rest of the time in California.
I was curious if you've been working with any farmer cooperatives. I'm from northern Idaho, dryland farming, and if you have, if there has been any kind of movement between the cooperatives to block GMOs from entering the cooperatives.
Not that I'm aware of.
It's been very obvious for many years that there's an actual corporate media blackout on these issues. But social media is still very strong. Is your lecture available to be able to be posted on social media to kind of circumvent the blackouts?
Well, a presentation similar to this was recorded in Seattle the 15th of September and is on YouTube. It's more concise, and it's a real challenge as we continue to get more and more information. I shortened this one up tonight a fair bit, and I didn't explain everything in his detail, and I was under the perception that quite a few of you folks had a reasonable understanding. It's a challenge because you don't want to put them to sleep because you're sitting there for who knows how long, and it's a complex subject. It doesn't take long for the deer in the headlight to arrive in some occasions, and how do you leave any of it out? I snipped it down a little bit. How do I leave more out? But that one is like an hour and a half.
I feel like it's important to reiterate that your focus here was less on GMO technology in general and more on Roundup Ready and herbicide-resistant genetic modification.
There's no question that the primary use of genetically engineered crops to this point in time has resulted in increased use in pesticide. But it will be a colossal mistake of my belief that if anybody refuses to look at this aspect of genetic engineering, Dr. Pesticide taught me from the very beginning. He did the only early study that was properly done. Everything was simultaneous. They had all the controls in place. It was a tremendous study. He made the mistake of telling the truth before the study was published, and they destroyed him in a matter of 3 days. But that foreign protein aspect, in my mind, is the #1 problem to this technology as it's currently used. Again, I'll reiterate, fix the technology, get rid of the side effects, and it could be used right.
I've heard some pretty shocking numbers relating to pesticide use dealing with the United States non-organic cotton crop. Do you have any information regarding that, dealing with the GMO issues?
I don't have any specific numbers, but the 3 years that I learned what I learned about cotton, they keep the sprayers running just about year-round when the crop is growing.
And could you elaborate on what happened to the Iowa grape industry in the 50s? Iowa used to be one of the largest producers of grapes in the United States, and today, what's the answer?
Well, as I explained, and I failed to mention grapes when I explained the volatility of 2,4-D and dicamba. You can spray it today when it's a nice day, and then it can warm up, and the humidity can come up, and it can get up and move. I said you could take the lid off the jug and drive down the road and kill half the cotton in the south. Well, the grapes are pretty much the same sensitivity. Exactly. It's death. The drift of 2,4-D or dicamba is death to a vine. Yep. Thank you folks all very much.
Yeah, thank you all very much for coming. Please don't forget to contribute to GMO-free Jackson, and if you have any little left over at the end, also to Howard's traveling expenses. Thank you so much.